multiple kids have told him that he teaches a lot like me. And I was like, well, that's either a good thing or a bad thing. I'm not sure what. So let's grab a seat and get out graph paper. We might want to use algebra tiles today, so if we reach a point where we want them, I might as well get them out for us. I know, because you're not paying attention to what we're doing. Otherwise, it wouldn't have scared you. Yeah, but unless you can tell me how to complete the square on a quadratic equation like we're going to solve at the end of class, you should probably put that away.
How to complete the square? You add smaller squares.
What do you mean?
Like if it's not a complete square, just add more squares.
This is on our homework.
So, like we saw yesterday, perfect square equations are real nice. Even when they're not nice, they're nicer than the other not nice. Because we can take the square root, we can leave it in radical form, we can subtract or add anything else that we have that is extraneous, and get our values, get our zeros, right? So, if we have equations like this, is A perfect square? I mean, 1's a perfect square. What's the problem with? I mean, yeah, B's also a perfect square, but actually, when we have a perfect square equation, we don't need B to be a perfect square.
B isn't a perfect square anymore. But for A, you gotta do 2 plus 2 would have to equal 2 times 2. Yeah. And, well, no, it would 2 plus 2. Well, 2 times 2 makes 4, so the 1 would have to be 2 plus 2.
Right, and that.
For a perfect square.
All right, let's forget about what we're trying to. We're trying to like shove this into a box that it may not go into.
No, yeah, I said
solve that. Go ahead and try to factor A. Just solve it however you know how.
However we know how.
However you know how.
Algebra tile time. It's missing 3. I already thought of that. I'm smart. It's not the algebra tiles. It's me.
It's missing 3.
Yeah.
Well, what do you mean? Tell me more.
To be a square. It's kind of like a heart shape currently.
You're absolutely right. It kind of looks like the new CVS logo if we rotate it. I can't believe you just spotted that out of nowhere. But CVS redid their logo. It's kind of more pixely or whatever you want to say.
Why did they do that?
I
Because
don't
they
know.
want to be hip.
So, okay, so the problem is when we factor, we said we're looking for dimensions. And we're factoring out the area of an object. But when we have dimensions that multiply to make the area, we assume that's a length and a width. So what Connor is saying is to make that work, we're really lacking these 3 tiles. Is there a way that I can make my shape have 3 more tiles? Algebra, right? Algebra says do whatever the heck you want, except now, if I add 3 to both sides and make that 4, my 0 is 3. Right, because I added 3 on both sides. Well, now, if I look at it like this, it could be factorable as x plus 2 and x plus 2. Or actually,
And that's the same equation.
it's actually got another option of factorable. Huh? Is there another way to factor it? If I move, if it wasn't, could it make a rectangle that isn't a square?
X minus 2 and negative x minus 2. Well, yeah, it could.
X plus 3, x plus 1.
Well, it could, but it'd be different because you'd only be adding 2.
Ooh, yeah, because then the constant would only actually be 3. Alright, so let's go ahead and just be happy with one way of factoring then.
We can't
So
do
if we had
that.
x plus 2 squared equals 3, so we now said x plus 2 squared equals 3.
Which is the same equation on top.
Oh, hey, look, that's this equation.
Yeah.
Oh, hey, fancy that. So what would we do to start solving this?
They did that on purpose, maybe?
The square root it. Yeah.
It's probably an accident, right? Nobody would have planned that out.
Yeah, CPM's not that smart.
Plus or minus the radical value. And then we said the nicer. I infected another student with that last night. I was tutoring and I was like, "Oh, have you heard the quadratic equation song?" And he's like, "What are you talking about?" I was like, "Ooh." So now we would have x equals.
Tutor?
Yes.
How much you charge?
$60 an hour, so $1 a minute essentially. I am cheaper than other people. I have not raised my price in 3 years.
Really? You're cheaper than other people?
I'm more expensive than Mr. Hall. I don't know why he's clinging on to his price, but
Wait, he tutors?
I'm not sure exactly. I think he charges different stuff depending on the content.
That makes
But also part of his tutoring is like through Columbus State, so they pay him. So that's different when you're getting paid like by a school versus by an individual. But guys, a lot of what I tutor is like high school tough math.
Do
like-
high schoolers?
Like I tutor like pre-calculus and calculus and like diff EQ. I've done it. Pretty much every high school class we have I've tutored.
So does that mean if I need help with a problem, I can call you?
Yeah, but right now I'm your teacher.
Okay, yeah,
Once I'm not your
no,
teacher,
in high school.
yeah.
Wait, do you tutor your past students?
A lot of times. If you guys, I doubt you know the Needlemans, but I still. It's just the
The-
last name of a family.
The thing is, I don't think I could afford that. My parents might be able
So-
to.
Not the same.
This. It wouldn't be you paying me. Of course it'd be your parents. This is the technique called completing the square. Because when we look at an equation like x squared plus 4x plus 1, that original equation that we had, equal to 0, let's put that into Desmos. Right, so you don't have to pull your computer out if you don't want to.
Yeah.
But if we put this into Desmos,
Laziness. OP. You use Firefox?
I do.
You just realized that?
Well, I use Chrome too because a lot of things are Chrome because we're like a Google district. X squared plus 4x plus 1, we said. These roots are like garbage sauce.
But I think it equals the same thing
Oh,
as
that's
what
how
you
we
saw.
were supposed to do the homework.
But these are the rational approximation of this actual value. So this radical answer is better. Not even the same, it's better than the decimal value. We always would prefer the radical value as opposed to the approximation, because the approximation is just that. It's an approximation. All right, so we are going to move on to, because this makes sense to you guys kind of quickly.
Yeah, but if you use approximations, you can say I'm approximately as smart as a high schooler.
All right, try these on your own. I shouldn't even give you the visual, but
And then you, okay, I'm going to go up to the point.
Oh, yeah, we haven't gone up to the board in a while.
okay.
We have to
There's the
add
other pen.
1, 2, 3, 4 to both sides. 4. So it's x plus 3 squared. I draw very well.
I was about to say, wait, what?
So then you take the square of both sides. So x plus 3 equals 4. You subtract 3 equals.
Hey, you gotta
x
slow
positive
down.
equals 4.
You got to slow down because things you're saying are incorrect.
I like going fast.
I know, but things you're saying are incorrect.
Equals.
And I think you're just saying it wrong. But we got to actually show the
sit
work,
on
or I
this
need to
thing,
make you guys, or I need to make you guys write it on paper. As you said, x plus 3 equals 4, and actually the square root of 4 is something we can do.
Yeah, it is.
We're going to get actual numbers
oh my
here.
gosh, that's a first. Okay.
So we get -3 plus or minus 2, so we can actually write out our two answers that we get.
Oh,
What's -3 minus 2?
-5.
I like to give the smaller value first and then the higher value. Even if they're both negative, I just like to start smaller than higher.
-1.
Now, what's weird, well, what I should say is, okay, so these are nice, right? Everything we've been doing so far uses all addition.
Well, except for the plus and minus.
They also do diamond problems?
I feel like they've been doing diamond problems.
Diamond problems are like a CPM.
The beginning.
Yeah.
Is it just so you can learn quadratics? Do
I
they just
mean,
teach it to you,
Actually,
like,
it goes back to number sense. Like, number sense is a big standard that we teach you guys, and it really is like just being able to see numbers and work with them. So, what gets challenging is, wait a minute. Wait, before you even write, do you see what's up with that picture?
These are negative.
Those are negative tiles that actually don't have anywhere to go right now because there's no way for them to have been created.
We need to add one both sides.
But we still, so then we have 4
No,
negatives?
no, then we have to add 6 on both. Oh, is that a 6? Oh, that was a 0.
All right, so for the sake of I need to be a teacher, go back to your desk. Let's grab our paper. You are correct, but this is where kids start to make mistakes. So this is why I want us to write it down. The process we need to follow is asking ourselves, what do we want the constant to be, and then how do I get there? So you guys all kind of together took this process. We want the constant to be 1. But to get there, we add 6. So then, I actually shouldn't do parentheses
You
yet.
have to add 2 positive x and 2 negative x, right?
If we add 6 to both sides, so pick up your pencil, scoot your computer away. We haven't done anything but add 6. Because we didn't like the fact that we had a bunch of negative tiles that had nowhere to go when we try to actually build this. So now, we have x squared plus 2x plus 1 equals 6. We don't really care about this side. Like, it's there, but it'll just do whatever we tell it to do. That's gonna come back around. The whole we don't really care about this side, it'll just do what we want it to do. That's gonna come back around. So now this becomes x perfect square 2 times the square root of the perfect square. Right, so we know it all works. Yeah, remember our b value in a perfect square trinomial is double the square root. Yeah, and it gets more complicated if there's an a, but go ahead and finish this on your own. Go ahead. We don't know. Well, it's somewhere between 3 and 4. No, somewhere between 2 and 3. We should get x equals -1 plus or minus radical 6. So now let's take a moment to self-check. Try this on your own. On your own. So try not to think out loud. And if you get A, move on to B, because obviously it's more challenging, because things are both well, I don't know if it's more challenging, actually. Use those algebra tiles if you want. This album is literally called Why Try Harder.
Do you want us to do all of it?
If you can. But this song is called Weapon of Choice, as we choose which mathematical weapon we're going to use to factor these quadratics.
Oh, it isn't a. It's all negative. I don't like that.
Huh. C has a 1 on the right-hand side, whereas A and B didn't have anything over there. I just caught that, so make sure you pay attention to that.
How did you do B? I don't like it. No, never mind.
It's all making what we want.
It would be really hard to solve, but I can just leave it in radical form.
Yeah, most of the time we leave it in radical form.
Am I supposed to have a lateral number as part of the answer?
Might, if we end up square rooting a negative. What do we want this to be? The trap door is students will think add 4. Hmm? So here is what I was really getting at.
Okay, I did it right.
The trap for most students that I have taught in the past that end up struggling with this is the number that you want your constant to be gets stuck in your head as the number we're working with. But we're not adding 4, we're trying to get to 4, so we're adding 9. Here's a trick I got that you can take or not take. All we really care about are these. We don't care about the constant they give us because we're going to make the constant whatever we want because algebra says I can do that. And I can also mess with the x's and the x squareds, but that gets complicated.
And we don't know that yet.
So, if it helps your brain, kick the constant to the other side. When you start these problems, just say, get out of here. Put it over there and then make it just do whatever we do to this side. So if I do that over here, now the image that I had drawn first without the green, that's what I got. I'm going to make it equal to 5 at some point. But now I say, okay, I can add 4. Or from the get-go, you could have added 9. Either way, we get to the point of x squared plus 4x plus 4 equals 9. What?
I just don't see
Never mind, that's really going ahead.
Are we good? I mean, we might not be, but
Honor's never good.
Yeah, that is true.
cool. True?
Yeah.
Okay. What do I do?
Square root both sides and get x plus 2 equals 3 and
Plus or
plus
minus
minus 3.
Careful, they're ready. They're so ready to jump on you.
And then
After the past couple days where you've been like, I got it right, you got it right.
Oh shoot, I forgot the negative.
Oh shoot.
That means negative.
we had one of these questions.
And actually, it's not or, as I'm about to write it, it's and. Like, the solution for this equation is negative 5 and, so we put a comma, 1.
Can we just write one?
Yeah, so like x negative 5 comma 1. We're literally making a set of the solutions. So eventually you'll work in set notation where we put all of our answers in one of these
see
things.
that set
What if we
notation.
had like a
Isn't that what
wavelength
you do
thing
for
where it
the
had
game?
like tons of
Yeah, that's what domain and
Practice. I said exactly what you're saying to Mr. McCauley in room 40 whatever at Coshocton High School. Trust me, it's just practice. So over here, what I really like to do is ignore the constant and just like work whatever I want to work. So negative 6x, I like to draw in red just because I can't really.
Hey, Sean.
Empty versus filled isn't really useful.
Yes. Hey, there's a big argument in the hallway outside.
Yeah, I second that motion.
Oh, you're right there.
So wait, if this is negative 3x and this is negative 3x, positive 9.
Wow!
We gotta fix this and make it positive 9, so what do? Add 10,000.
And then we can get
Careful with your signs.
-3.
At first I thought it was a difference of squares, which was really confusing.
Yes, that's what I thought, but then it was like, no, that's
But that becomes positive.
yeah.
And with that being negative,
It would be,
wait, I don't need that
yeah,
anymore.
you don't need that anymore. You would just do
Ha,
x
no more
minus
parentheses. Get wrecked.
3. X minus 3 plus or minus
Square root of 10.
radical 10.
Well, that's not.
Same thing.
Radical dude.
So now positive 3 plus or minus radical 10.
Or yeah.
Who? Radicalism is the way to go. You go home and be like, my teacher is trying to radicalize us. You get a scathing email from some parents that misunderstood.
What's radicalizing?
It can mean a lot of things. Like, so I have recently been turning on Seinfeld while I grade papers, and there's this big thing, because it was back in the 90s, about Kramer being a communist, because back in the 90s there was this whole, maybe 80s too.
This is
Um,
still anti-communist.
Well, right, but there was this big push in America to like become a communist. Like communism is good. So if I was here like trying to like get you guys to like go out and promote communism, I'd be like trying to radicalize you. Because you're trying to like, yeah, get you to a radical place. You can be radical on your own.
Anarchy.
Someone who's trying to radicalize you is trying to pull you to a really extreme. Does that make sense?
Okay.
Alright, so like I'm trying to radicalize you with math knowledge, I guess you could
That's
potentially say.
illegal. That's political beliefs. Math isn't real.
These are made up facts.
Yeah. Exactly.
Alright, so with negative 2x, what's my constant wanna be?
301.
A positive 1. So what do we need to do? Add 4. Jake, I'm worried I'm going to give you guys a mastery on this on Friday and you're not going to have practiced it enough.
But you don't need the parentheses.
Would you be ready for a factoring mastery?
Probably.
I think you'd be ready like today.
Parentheses out of there. I don't like.
The only way you figure out where you're going to make a mistake is through practice, right?
Yeah, but not masteries. Practice their different assignments.
No, but like this, what we're doing right now. Did you already have it written down? Okay. That's what I was just trying to make sure. Because you really like those tiles. I think your artistic brain just really likes those tiles. Alright, all you mathematicians.
Are you calling us nerds?
Yes.
All you cool cats are kids.
Challenge.
Are you
I get
cool
called
cats?
tryhard.
Challenge.
Is it challenge?
Shut up.
Challenge.
At least it's
do
even.
the hard
This
side of
which
it.
I don't know if we could even do it if it was on.
I'm not a
It
tryhard.
wouldn't be a
Shut
search.
up. No, I'm not. Okay, that's
Why do
a
you-
lot to say.
Okay, I would like you guys to be a tryhard right now and try to factor this equation.
This only nerds factor equation.
Good. I'm glad I got a class of nerds.
Wow. I love that.
It's not offensive if it's true.
That's
Or if you
that's
get
not
offended,
true.
or if you get offended, it's probably true.
Yeah, that one I can see. Oh no.
What? Oh no.
There's
What?
2x squared. I don't like it.
Yeah, nor do I. Oh.
Who's the tryhard now?
Wait. How do you date? But
Remember that we can do anything we want. Well, as long as we follow the rules of algebra, we can do anything we want.
I don't like it. Wait. Going back.
You backing it up, putting it in reverse?
Yeah, no.
Should I just put on like old school hip hop when we're solving math problems? Because like you're all kind of bopping your head like.
I'm bobbing my head because I don't get this math equation.
Jake, you want to try to guide us? Because you said you think you know.
So I think we add 15 to both sides.
You did what on both sides?
I added 15
We added 15.
and then factored out 2.
Okay, so we added 15 on both sides, getting us to. Come on.
Oh, smart.
Oh, because we don't like the 2, let's find a strategy to get rid of it.
I tried that, but wrong.
So I think there's probably lots of things that we could do prior to factoring out the 2, but okay, I'll follow Jake because he's normally got a pretty good brain on his shoulders. 26. Okay, well that feels big, but whatever. If I factor out 2 on this side, does this stay 26 or?
Yeah, it stays 26 if you're not changing the equation, you're just moving stuff around.
We didn't actually divide by 2 on both sides if we keep the 2 over here, right? Because we're not actually trying to change what we have. We're just trying to change how it's written. So my right-hand side stays 26.
And then you factor out to x squared, x plus 3 squared, 2x plus 3 squared equals 26.
Do you have something in your mouth?
Okay.
Okay.
I wonder where he got those.
Yeah. That
Equals 26, and then we divide by 2 on both sides, and you get x plus 3 squared equals 13, and then we can solve it from there.
So wait. When we did this, could I have divided
Yeah, that's
both
what I
sides?
was
Wait,
thinking. That's what I did. And then
Here's-
it's basically-
Here's the mistake I'm trying to make sure we don't do. If the 2 is here, nothing happened over here. When we get rid of the 2 on the left-hand side, that's when we actually divide by 2 over here. So when you factor something out, that's not division. You're just rewriting. Right? Factoring is just rewriting. Now we're dividing by 2. Ooh, 13, that's going to be fun to square root.
we don't have to.
Nothing like square root and prime numbers in the morning.
Wait, yeah.
It's like a breakfast of battery acid and rusty nails.
Is that
Is that a reference to something?
I feel like it was in a movie at some point, but for the life of me, I can't remember. I did, Marcus Garcia, shout out to him, not that he'll ever see my YouTube videos, was our drum instructor in high school. And to like make us scared of him or whatever, he used to say that he would eat a breakfast of battery acid and rusty nails every morning. We were always like, there's zero chance you do that. And then one time he was like trying to like Hulk out and be like, yeah, and these drum heads are made of Kevlar, they're bulletproof. And he takes his stick and goes and stabs right through the drum head. And they literally are made of Kevlar. Like, it's woven Kevlar, but it's not as much as like a bulletproof vest, because the bulletproof vest is just layers, just lots of layers of Kevlar to slow down the bullet until it stops. So, story that doesn't need told. He accidentally stabs through the drum head, and then the band director goes, "All right, let's go!" And we have to like start doing like taps, like the whole like when you're marching and like the drum line's playing taps. So Marcus is like, and just starts playing the drum beside him, like because there's another person right there. It was like one of the funniest things ever. We would not let him live that down because
Oh, he was a classmate.
yeah, like we were out marching, like in marching band.
He wasn't like the instructor.
No, I mean he was our drum instructor, but he was like a senior. He was like in charge of the drum line,
Oh.
but he was also in the drum line. Yeah, it was good because you know the band director walks around as we're marching, and the band director saw him drumming on somebody else's drum and was like,
No
"Good
morals.
times, good times." I feel somewhat morally
We're
gray.
talking about morals and connection.
Well, it's a gray area
I
for you to
guess
be eating thieved food in my class. I don't care. I don't really
She
care.
doesn't care.
I know her bag of mints is ginormous, right?
It was lost and found.
Wait.
What? I don't know if I
Oh.
would eat lost and found mints.
No, it was lost because it all got dropped on the floor and then Jake picked it up.
All right.
But it
Does
had-
completing
and
the
I
square
helped her pick the rest of it. Just-
does completing the square make sense?
Yes.
Do you want to go back and look at any homework questions from yesterday?
No.
No, I'm good.
There was one, but like I just used Desmos to solve it, so I'm good.
I mean, now things should make more sense with another technique in our toolbox. But that's completing the square. So I mean, unless we're trying to like do more than one lesson a day, which I don't really need to, we're on a good pace.